This is called as the rotation, and we have the axis of rotation. What is axis of rotation? It is the line connecting the two stationary poles and passing through the center of Earth. Okay, we call it as axis of rotation. And then we saw the orbital plane, the plane in which the Earth revolves around the Sun. And in case of Earth, the axis of rotation is not at 90 degree with respect to orbital plane. So it is tilted at an axis of, from its normal position, it is tilted by 23.5 degree. Okay, that brings its position to 66.5 degree towards, from the orbital plane, you can see. Fine. And so I also told about the circle of illumination, that is, which divides the regions of the day and night. And with respect to the period of rotation, there was this concept of the solar day and sidereal day. Let me just explain again what is solar day and sidereal day. So some of you might be confused about this. Yeah. So period of rotation is basically like the time taken to complete one complete rotation, how much time it takes. So if we calculate the time required to complete 360 degrees of rotation, exact 360 degrees of rotation, we call it as sidereal day, which is equivalent to 23 hours 56 minutes. And if you want to see the time taken to see Sun again, we will have to go beyond 360 degree, because the Earth is not stationary. If the Earth is stationary, in that case maybe 360 degrees of rotation would have brought us straight to the Sun back. है ना? If at all the Earth was stationary, after 360 degrees of rotation we should have been able to see the Sun back at the same position. But since the Earth is moving, it is not stationary. Even after 360 degrees of rotation, the Sun is not in the same position. We are yet to reach the position of the Sun after 360 degrees of rotation. So for that we need to move some more degree, maybe 361 degree, 362 degrees. That excess rotation is required, because Earth has moved from this position to this position. So the time required to complete 360 degrees of rotation is called as sidereal day, and the time required to see the Sun exactly at the same position in the sky again, that is what is solar day. है ना? Simple concept है. I hope Tushar is clear about this now. Right? And then I told you the concept of the linear speed of Earth's rotation. है ना? Because of the rotation, the objects along the different latitudes also are in kind of rotational motion. है ना? An object located along the equator will have to travel a longer distance in the same period of time than an object which is located near to the temperate regions. है ना? Maybe at 60 degree latitude, it has to cover only the smaller distance in the same time, 24 hours a time. So basically this object has to move in a faster speed than this. So that's why the linear speed of rotation at equator is highest. So that gives the momentum also highest. The momentum which is conserved by any body, the momentum which is held by any body near to the equator is higher. So if you launch a rocket from here, so it will have greater momentum than the rocket which is being launched here. So that's why the rocket which is being launched here would require lesser fuel. So there are higher chances, because ज़्यादा fuel है तो ज़्यादा weight होगा, and more the weight there are more complexities and lesser chances of launching. So इसलिए we prefer to launch near to the equator so that we can conserve the fuel and make the rocket more efficient. है ना? And which is that location? Kourou exactly located near to the tip here. है ना? Near to French Guiana. It's located in French Guiana. That's the country's name. So that is related to rotation. Revolution is basically the movement of Earth around the Sun, and I told you the Earth revolves around the Sun in an elliptical orbit. And that too, even the Sun is not at the center of this ellipse, it is located in one position. So that makes the earth closer to the sun at one position and very far away from another position. The closest position is called as perihelion and the farthest position is called as aphelion. And what is the time taken for one complete rotation? It is 365 degrees, 5 hours and 48 minutes. That extra 5 hours and 48 minutes we will accommodate in once in 4 years. And what is the direction of rotation? In case of rotation, it is the direction is again from west to east, or if you view from the north pole, we will see it as counterclockwise direction. In case of revolution, it's again west to east, or if you see from the sun's north pole, we will see earth revolving in counterclockwise direction. The next one is the most important, seasons. Okay, I'll explain again what is season. What is season? The change in the conditions, weather conditions, the temperature, precipitation, the pressure conditions, that changes in a same place from one part of the year to another part of the year. At one particular time itself, the weather and temperature condition is different from one part of the earth to another part of the earth also. है ना? Currently we are in August. We are like almost feeling kind of summer खत्म होने वाले है ना, but in the southern hemisphere अभी winter खत्म होने वाला है. The temperature here it is starting to drop, but in the southern hemisphere temperature would be starting to rise. That difference within the same time and in a same place with different time. Now we have summer, after 4 months we will have winters, है ना? We have many such different seasons. There are basically 4 seasons: summer, winter, spring, autumn. So what is the reason behind that? I told you there are 3 factors behind this. The first one is rotation of earth. Second one is tilt in the axis of rotation. Third one is revolution. Suppose if all the 3 factors are not there, what would be the condition? Earth is completely stationary, it is not even moving, it is not even rotating, it is not even tilted. So what would happen? Exactly half the side of earth would receive the sunlight 24/7 into 365 days. The other side is completely dark. This side it is completely bright, this side it is completely dark. So this becomes very hot, this becomes very cold. If we bring rotation, so this difference will be equalized. The portion which was receiving sunlight for 12 hours will start to receive the darkness for 12 hours. यहाँ पर it was under the sunlight, now the same position will come back to night for next 12 hours. Because it is almost straight, there is no inclination, there is no change in the sun rays. So basically all the positions along all the different latitudes would receive the sunlight for same duration of time. 12 hours of day, 12 hours of night, 12 hours of day, 12 hours of night, 12 hours of day, 12 hours of day, 12 hours of day. There is equal day, equal night. So this is when the rotation is there, there is no tilt, there is no revolution. And what would be the angle of incidence? Angle of incidence would be 90 degrees across the equator. The sun rays are falling vertically 90 degrees across the equator. From equator towards the pole, the angle of incidence starts to decrease. Maybe at 45 degrees, the angle is 45 degrees. At 90 degrees, the angle is 0 degrees. That means the sun rays are almost going parallel to the surface. So the surface will not be able to observe anything. The temperature drops to a great extent. Temperature is highest near to the equator, and from equator to pole temperature drops, both in the northern hemisphere as well as in the southern hemisphere. So which latitude will receive the highest insolation, highest sunlight? Equator. The intensity of sunlight is more, it absorbs the sunlight more. Now let's bring the second factor. Let's tilt the earth by 23.5 degrees from its normal position, but the sunlight is in the same direction. You tilt the earth by 23.5 degree, the position of equator, Tropic of Cancer, Tropic of Capricorn, everything is tilted by 23.5 degree. But the sun rays are still here. So basically when the earth was receiving the 90 degree sun rays at equator, now it starts to receive at Tropic of Capricorn because I have tilted on this side. So now here you can see at the equator it is still 12 hours of day and 12 hours of night, because this central position is still across the circle of illumination. But here can you see, as we move towards the northern poles, okay, take for example at 30 degrees tropic of latitude, यहाँ पर रखो 23.5 degrees से मानते हैं. Here the portion of the northern hemisphere which has started to receive the day is much more than the portion which is receiving darkness. Maybe here it is 15 hours of day and then 9 hours of night. Here it is 20 hours of day, 4 hours of night. Beyond certain point, it's always day, it's always exposed. I hope you can imagine. In this position, the earth is completely straight. It is rotating like this. The sunlight is falling equally along all the different latitudes. Here, in this position, it has tilted. The sunlight is reaching only up to the North Pole. Now it is reaching beyond North Pole up to till here. Now if you can imagine, in this position, in this entire region, even after the complete rotation, one complete rotation होने के बाद भी still it is always exposed. That is what we call it as day. You know, day and night. Why day and night is there? Because with rotation some portion would be exposed to the sun, some portion will be away from the sun. But because of the tilt, some regions are always exposed to the sun. It can never hide from the sun. That's why it will have 24 hours of day. This entire region will have 24 hours of day. Because it can never get exposed. Sorry, it can never get away from the sun. It's always exposed. Here it is opposite. Can you see here at this, maybe it is 9 hours of day, 15 hours of night, 4 hours of day, 20 hours of night. But beyond this point it's always 24 hours of night. Now can you guess what is this latitude? कहाँ से 24 hours of day would begin? Not that difficult, because we have tilted the earth by how many degrees? 23.5 degrees. So 90 degrees से 23 minus कर दो, you will get 66.5. So basically beyond 66.5 degrees of north it's always day, and beyond 66.5 degrees south it's always night. Because हमने यहाँ पर तो 90 था, ऐसे टिल्ट कर दिया. कितना टिल्ट किया? 23.5 degrees. The sunlight was receiving at 90 degrees here. Now it will start to receive at 23 minus 23 and half minus कर दिया तो 66 and half degree. The maximum reach of sunlight in the southern hemisphere is only 66 and half degree. Beyond that sunlight will never go, because even after the one complete rotation, this is always away from the sun. It is always hiding from the sun. It can never get exposed to the sun. And the second condition, the sunlight is falling vertically. The sun rays is falling vertically 90 degrees at 23 and half degree north. Why 23 and half degree north? Because we have tilted equator को भी ऐसे tilt हो गया. Once the position is tilted, even the equator is also tilted by 23 and half degree north. है ना? So now rather than falling at the equator, it will start falling at 23 and half degree north. So from here, the rest of the northern hemisphere, you can see the angle of incidence. Earlier it was bit lesser. Now it has started to increase. The sun ray starts to fall more vertically. Complete vertically तो 23 and half degree, यहाँ पर तो थोड़ा सा intensity बढ़ गया, because of which the temperature rises in the northern hemisphere, and we call it as it is summer in the northern hemisphere. We experience this, है ना? तो suppose if you are in the equator, you would not feel that much difference between the summers and winters, क्योंकि it is यहाँ पर भी it is 12 hours of day, 12 hours of night. Here also it is 12 hours of day, 12 hours of night. But as you move from equator towards the polar region, you might have seen during the summers, if you are in Delhi, the sun sets at 7 o'clock. The peak summer 7:30 tak there will be brightness. What about London? We are here, London is here. The sun sets at night 10 o'clock. Till night 10 o'clock its brightness. If any of you have been to London or Paris or even New York for that matter, which is all located in the higher latitudes, or if any of your relatives are there, you can ask them. The sun sets very late because the duration of the day is more during the summers over there. And if you go beyond 66 and half degree, it's always brightness. The sun never sets. That is what we call it as the land of midnight sun. The polar region is also called as the land of midnight sun, है ना? So first thing, the sunlight has started to fall for more duration of time, and second thing is the intensity of sunlight has also started to increase because of the angle of incidence, increased angle of incidence. So that rises the temperature, and we call it as summer in the northern hemisphere. So here the duration of sunlight has also reduced, and the angle in which it is falling, that has also reduced. There is more slanting angle. So that's why the temperature would drop. We will call it as winter in the southern hemisphere. So whenever there is summer in the northern hemisphere, the conditions are opposite in the southern hemisphere. Now let's bring the third factor also, revolution. Revolution में क्या होगा? Earth would not change its axis of tilt. Can you see it is tilted in this direction? It is also tilted in this direction here. It is also tilted in the same direction, same direction. It will never change the direction of its tilt. The direction of tilt is always fixed all through its revolution. This is the character which is responsible for the change in the season. कैसे होगा? So at this position it is tilted, the northern hemisphere is tilted towards the sun. At this position this is tilted away from the sun. The southern hemisphere is tilted away from the sun, and the southern hemisphere is here tilted towards the sun. That brings the condition opposite over there. Can you see here? The portion of the southern hemisphere which is exposed starts to increase from equator towards the pole. Here it is 12 hours of day, 12 hours of night. Here it is 16 hours of day, 8 hours of night. 20 hours of day, 4 hours of night. And beyond Antarctic Circle, it is 24 hours of day. It is always exposed. Even with one complete rotation, it's always exposed to the sun. So we will have 24 hours of day in this particular region. Opposite, यहाँ पर, here it is 8 hours of day, 16 hours of night, 4 hours of day, 20 hours of night, and beyond Arctic Circle it is 24 hours of night. This 24 hours of day, 24 hours of night, exactly opposite what we had seen earlier. So this is called as winter in the northern hemisphere. This is summer solstice. This is winter solstice. Remember the word solstice. Solstice matlab which is predominant. Here it is, the summer is predominant. We are living in the northern hemisphere, so we will tell it is summer solstice. Summer solstice means it's summer in the northern hemisphere. Winter solstice is winter in the northern hemisphere. So now you might understand why even though during December, January, the earth's position is very close to the sun, still we will have winter because we are tilted away from the sun. Near to the June, even when we are at a farthest position from the sun, because sun is not here exactly, sun is here. For our representation we have told here. Even though we are farthest from the sun, since it is tilted towards the sun, we will have summer. You might ask, itna difference hai, there is so much of difference in the distance, will it not matter? No, it will not matter. The distance between the sun and earth is so huge. It is so huge. This distance, this difference would not matter. But the difference between the one place and the another place on the surface of earth would matter. How that difference is causing? It is causing the duration for which it is exposed. Earlier it was exposed for 12 hours of day. Now it is getting exposed for 16 hours, 18 hours. So that brings more sunlight, that rises the temperature. And the angle of incidence has also increased, that rises the temperature. So that causes it summer. It is not the nearestness to the sun or away from the sun. This is called as winter solstice. So when you bring the revolution, this would happen. So now what is the reason behind the seasons? It is the revolution of earth in a tilted axis of rotation, which is the more predominant of all the three. I would say this is the tilt. Without tilt, even if there is rotation, even if there is revolution, we will not have season. The tilt makes it the difference, that because of the tilt, at one position it is tilted towards the sun, at one position it is tilted away from the sun. That difference causes the season. You just have rotation and revolution, it will not cause season. The tilt axis should be there, that too the fixed axis. Now we have a third position called equinox. This is summer solstice, this is winter solstice. In between we will have position of equinox. What is equinox? Equinox is the position when the earth's tilt is neither towards the sun nor away from the sun. But मैंने तो बोला था the tilt is always fixed. So how can it be neither towards the sun nor away from the sun? But the revolution is such that even with the tilt, the sunlight can fall vertically along all the latitudes. I'll show. Let me just take this luster as example. Okay, so this is sun, okay, this is earth. You see the northern hemisphere and southern hemisphere. When the northern hemisphere is tilted towards the sun, we call it as summer. And if the northern hemisphere is tilted away from the sun, we call it as winter. है ना? What about this and this? Even though the tilt is there, the sun rays are falling equally along all the different latitudes. है ना? The tilt is neither towards the sun nor away from the sun, but still the tilt is there either this side or this side. है ना? This tilt is there. So this kind of position will come. कैसे होगा? The tilt would not change. Can you see? This is winter, we say. From winter you bring the position here, but the sun's rays are falling vertically equally along all the latitudes, but here it is not equally among all the latitudes. It's more towards the southern hemisphere than towards the northern hemisphere. This is more exposed to the sun than from this. This is what we call it as winter. But here all the places are exposed equally. What about here? ऐसे घूम के here it comes. So this is the summer, this is winter, because this is more exposed, this is less exposed. And now what about this? All the places are equally exposed. And now all the places are equally exposed, even though there is tilt. That is what we call it as equinox. Can you see, here it is tilted towards the sun, here it is tilted away from the sun. But here and here, even though the tilt is in the same position, all the places are exposed in the same manner. Both here as well as here. When all the places are exposed in the same manner, this is what is the condition. Even though the tilt is there, the tilt is like that, us taraf hai tilt. So all the places are exposed in the same manner. So that makes 12 hours of day and 12 hours of night here. 12 hours of day, 12 hours of night, 12 hours of day, 12 hours of night, 12 hours of day, 12 hours of night. All across from equator towards the pole, from here to here, from here to here, here to here. So this 12 hours of day, 12 hours of night across all the different latitudes is called as equinox. So equinox position will happen twice a year. Once when it is changing from winter to summer, another when it is changing from summer to winter. So this, when it changes from winters to summer, we call it as spring equinox. When it changes from summer to winter, we call it as fall equinox or autumnal equinox. So equinox is the position when all the latitudes receive equal duration of day and night. So now tell me, during the summer solstice, so since the position is fixed all through the year, it happens at particular time only, particular time of the year only. Summer solstice always happen on 21st of June. On 21st of June, we will have summer solstice. And that means on 21st of June, we will have the longest day of the year. On 22nd December, we will have winter solstice. 21st March, we will have spring equinox. 23rd September, we will have autumnal equinox. In summer solstice, the sun rays are falling vertically at Tropic of Cancer. In winter solstice, the sun rays are falling vertically at Tropic of Capricorn. In spring equinox and autumnal equinox, the sun rays are falling vertically along the equator. Along the equator. In summer solstice, the length of the day starts to increase from equator towards the pole. In winter solstice, the length of the day starts to decrease from equator towards the pole. In equinox, the length of the day is same all across the different latitudes. Okay, Shivam is asking to explain equinox again. So let me explain again. तो इसलिए मैं थोड़ा सा slow ले रहा था. तो few of the students were telling that it's very slow yesterday. तो इसलिए मैं I tried to make it faster. So if you feel it faster, you please let me know. I'll explain again. Equinox. What is equinox? Equinox is equal day and night. Equal day and night position is called as equinox. During the summer solstice, the length of the day starts to increase from equator towards the pole and the length of the day starts to decrease from equator towards the south pole. During the winter solstice, the length of the day decreases from equator to north pole. But during equinox, all the latitudes would receive the same duration of light. 12 hours of day, 12 hours of night across all the latitudes. कैसे होगा? Because the Earth's tilt in the axis is fixed. It is tilted in this direction, and while rotating along the sun's axis around the sun, the Earth's position will come here. It is tilted here. ऐसे घूम के it has come here. We will have the difference in day and night only when the tilt is either away from the sun or towards the sun. है ना? Now I will show you again. Suppose you are the sun. You are the, let's assume that you are viewing as a sun. Comparatively, which hemisphere is more close to you, which hemisphere is away from you in this position? The northern hemisphere is towards you, southern hemisphere is away from you. Can you see? है ना? Can you see? With complete 360 degrees of rotation, this portion is always exposed towards you. Can you see? This portion is always exposed towards you. You can see this portion even with 360 degrees of rotation. There is like beyond 66.5 degree. ये जो portion है, it's always visible. Let me just mark you, तो पता चलेगा आपको. ये तो जाएगा नहीं. ठीक है. Can you see I have marked the Arctic Circle. Fine. So this, at this position, the Earth's tilt axis is completely towards the sun. So you assume that you are the sun. है ना? So I will rotate. Can you see? It's always exposed. The Arctic Circle is always exposed towards you. And can you see the Antarctic Circle? You cannot see the Antarctic Circle because this is always hidden from you. है ना? So if the tilt is like this, with one complete rotation, the Antarctic Circle is completely visible and you cannot see Arctic Circle at all. है ना? दिखता ही नहीं है. Can you see? It's not visible to you at all. So this is what we call it as winter solstice here. It is summer here, and here it is summer solstice here. So what about here? Even though the tilt is something like this only, can you see all the portions of the sun, all the portion of the earth equally? You can see north pole as well as south pole, all the parts are exposed. So that brings the sun the sun rays equally along all the different latitudes? What about here? Can you see? Both northern hemisphere, southern hemisphere, both are visible. North pole and south pole both are visible equally. No portion is hidden. So that brings half day, half night. So rotation में कैसे होगा? I'll just show you. So you are the sun. So this position is winter solstice. है ना? From here it will come in the same way. Suppose if you are here, it will be, if this is the sun, so this is away from the sun. घूम के यहाँ पर आ गया. Can you see it is equally exposed to the sun? With equal rotation, it is always exposed. You can see both northern hemisphere, southern hemisphere. Now it has come here. This is exposed towards the sun. This is equinox again. All the portions are exposed. I hope that is clear. So equinox is the position when the earth's all the latitudes are equally exposed, so that there is an equal day and night. So we have a question by Paras Yadav. Why everything moves in west to east only except Uranus? Did I talk about Uranus? Please hold on to this. We are yet to come to solar system. है ना, मैंने पहले ही बताया हूँ. तो आगे का क्वेश्चन अभी मत पूछो. Please hold on to this doubt. You will see in the next class when I talk about different planets. So we have another question. So why there is so much of temperature variation between north and the northeast? North and the northeast. Which northeast? Can you please clarify? Northeast of India are you talking about? The temperature variation of north and northeast of which part? Is it India or any other part? Not sure about this. Okay, you please clarify this query. I'll come back to that. So I have a small video. Okay, let me just show the animation first. So this shows in a better manner what I had explained. Okay, keep observing this. So here the earth is in winter solstice. है ना? Can you see the northern hemisphere is away from the sun, and you can also see the exposed part, the bright part, it is away from the sun, and this southern hemisphere is towards the sun. So here we have the summer, here we have winter, and as the earth moves there is no change in the axis, there is no change in the tilt, it comes as it is. This is what we call it as equinox. Can you see the tilt is as it is, but all the portions are exposed. You can see both northern hemisphere, southern hemisphere receiving the sunlight equally. Can you see here? The tilt is more towards the sun, and the northern hemisphere is receiving more sunlight for longer duration as well as for more intensity. The southern hemisphere is receiving the sunlight for lesser duration and with lesser intensity. So that brings summer here and winter here. this equinox, summer solstice, again this is autumnal equinox. Can you see autumnal equinox? Almost all the parts are receiving equal duration of day, equal duration of night. With one complete rotation, so there is 12 hours of day, 12 hours of night, that is autumnal equinox again. So again with the winter equinox, it comes back to the same position. The southern hemisphere is more exposed than the northern hemisphere. So Dhananjay is asking, sir, in equinox the axis of rotation and the circle of illumination coincides. So that's a very good question. It will not coincide in the way I had shown in this. It will not coincide in the way I have shown in this picture. है ना? The axis of rotation is not something like this, but the axis of rotation is something like this. So it doesn't matter that, see, this is sun and sunlight is falling. Here in this picture it assumes the axis of rotation is like this, but axis of rotation is not like this. So this is also kind of coinciding only. The axis of rotation is coinciding with the circle of illumination, but it is not completely straight. It is tilted, but the tilt is parallel to the sun rays. So it doesn't matter. When the tilt is towards the sun or away from the sun, it matters, but the tilt is parallel to the sun, it doesn't matter. Still it is coinciding with the axis of, circle of illumination. That's a good observation. Okay, I have a small video to show the effect of
to make
seasons.
one complete rotation around its axis.
So batch coordinator, please confirm if you are able to hear the voice.
How long does it take the Earth to make one complete rotation around its axis? 24 hours or 1 day? If we look at the same image of the globe, but from the top, looking down the axis from the North Pole, we see the Earth is rotating counterclockwise around the North Pole. If we look more carefully at this axis of rotation, we see that it is tilted relative to Earth's orbit around the Sun. Instead of being perpendicular, it's tilted 23.5 degrees. How long does it take the Earth to make one complete orbit around the Sun? 365 days, or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not in the center of the ellipse, but one of the focal points. Bottom line, the Earth is a little closer to the Sun every January and a little further away every July. Does that cause us to have seasons? Let's think about it. We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that our warmest season in the Northern Hemisphere? No. So the seasons must result from something entirely different. Let's return to the tilted axis of the Earth. As the Earth orbits the Sun, it goes through 365 daily rotations, while the axis maintains its tilt. On the June 22nd solstice, the tilt causes the North Pole to face towards the Sun, while the South Pole faces away. When the Earth's orbit takes it all the way around to the December 22nd solstice, the North Pole is now tilted away from the Sun and the South Pole towards. This tilt explains why the North Pole experiences winter in January, while the South Pole is experiencing the opposite season, summer. The North Pole is facing away from the Sun and gets less overall sunlight. The South Pole is facing towards the Sun and gets more. To understand this more fully, let's look more closely at how the sun's rays hit the Earth. First, notice that halfway in between July and January, during the September 23rd equinox, the tilt causes neither pole to face away or towards the sun. As the Earth rotates every 24 hours, each area of Earth's surface will receive 12 hours in view of the sun and 12 hours out of sight of the sun, 12 hours of day, 12 hours of night. Equal lengths of day and night is why this time is called an equinox. As the sun's rays hit the surface, they are strongest at the equator, directly in the middle, where they hit at a 90-degree angle. As Earth moves towards the December 22nd solstice, the North Pole tilts further and further away from the sun. At its maximum tilt on solstice day, the sun's rays are now hitting directly at 23.5 degrees south latitude, or the Tropic of Capricorn. Notice that every location within the Antarctic Circle at the South Pole is getting 24 hours of sunlight. As the Earth rotates, none of these locations is ever lacking in sunlight. This creates the summer season for the southern hemisphere. In the northern hemisphere, inside the Arctic Circle, the reverse happens. 24 hours of darkness, winter season for the north. As we watch the Earth continue its orbit, the Earth's tilt again moves towards the sun, such that when we reach the March 22nd equinox, we once again have all parts of the planet receiving equal amounts of sunlight and darkness. The equator once again receives the direct sunlight. At high noon, the sun would be directly overhead here. Returning back to the June 22nd solstice, we see the tilt move the North Pole towards the sun, so that the North Pole receives more and more hours of sunlight each day. At the solstice, the northern hemisphere experiences summer. All points within the Arctic Circle experience 24 hours of sunlight, and the sun is directly overhead, providing its most intense heating at the Tropic of Cancer, at a location 23.5 degrees north of the equator. As we continue to watch this process, we can see that the southern hemisphere moves through this one-year orbit from its winter through its spring, summer, fall, and back to winter, while the northern hemisphere experiences the opposite season. Note that each solstice and equinox represents opposite seasons in opposite hemispheres. The winter solstice in the northern hemisphere is the summer solstice in the southern. That means that sun lovers can plan trips to maximize their sun exposure, traveling to the southern hemisphere in December.
I hope that is clear. So you can draw this diagram in your notes in simple manner. If at all you have written till now, it's good. If you have not written, please leave some space and write it later. Okay, now you can write down the notes. Okay, you can leave some space for the diagram. Seasons are observed on the earth. Seasons are observed on the earth because the earth revolves around the sun in a tilted axis of rotation and the angle of inclination is always constant. Full stop. This brings the variation in length of day and night across different latitudes, which results in seasons. Full stop. Next paragraph. The regions receiving more sunlight for longer duration with the angle of incidence of sunlight being more vertical experiences higher temperature which we call it as summer. Full stop. The regions receiving lesser sunlight for lesser duration with more oblique angle of sunlight would experience lesser temperature, which can be called as winter, which is called as winters. Sorry. Is called as winter. Okay, next subheading, summer solstice. In the bracket, 21st of June. Okay, in that first point, the sun rays are falling exactly on Tropic of Cancer. Next point, the length of the day increases from equator towards North Pole. Length of the day increases from equator towards North Pole. Next subheading, winter solstice. In the bracket, 22nd December. 22nd December. The sun rays, the first point, sun rays are falling exactly at Tropic of Capricorn. Tropic of Capricorn. Next point. The length of the day, increases from equator, towards south pole and decreases from equator towards north pole. Next subheading, equinox. Equinox. In the bracket, 21st March, spring equinox, 23rd September, autumnal equinox. Autumnal equinox or fall equinox, both are same. The first point, the sun rays are falling vertically. The sun rays are falling vertically along the equator. Sun rays are falling vertically along the equator. Next point. All the latitudes from equator to the poles, experience equal duration of day and night. So next subheading, position of overhead sun. So we have a query from Aniket regarding previous topic about the shape of Earth, oblate spheroid. So centripetal force, how can the centripetal force due to rotation be the reason for oblate shape? हाँ, centripetal force का मतलब the force which is acting away from the center, है ना, it pushes. So basically that centripetal force pushes the things from the center towards outside. तो वो तो maximum होता है along the equator, because near to the poles the speed of rotation is less and near to the equator the speed of rotation is maximum. So there is more pushing. So that is the reason. So there is a kind of bulge near to the equator because of that. Subheading, position of overhead sun. So what is overhead sun? Overhead sun, I am talking about 90 degrees of sun. The sun's position if you are able to see exactly above your head. Can we see exactly 90 degrees of sun in Delhi? No. Why? That's because Delhi is beyond the tropics. Delhi's position is beyond the Tropic of Cancer. Okay, let me just show you. So this is our major countries of the world. So we have equator here, this is Tropic of Cancer, this is Tropic of Capricorn. I hope all of you have got your atlas. So today we'll mark some of the mapping. Keep it ready at the end of the class. So this is 0 degree, this is 23.5 north, 23.5 south. The sun rays would fall vertically along here, along 0 degrees. कब होगा? During equinox, both spring and autumnal equinox. है ना? So if you want to represent the earth, so this is what is, we have shown it over there. This is 0 degree, 23.5 north, 23.5 south. The sun rays are falling vertically along the equator curve, equinox, both summer and autumnal. So that means on the day of spring equinox, 21st of March, if you stand exactly on the equator, you can see at 12 o'clock you will see exactly above your head, sun. So that 90 degrees of sun will keep moving from here. Every day it shifts its position and reaches the maximum of 23.5 degree north. It reaches the maximum of 23.5 degree north because the tilt, the earth's tilt is aligned in such great extent that it is tilted maximum towards the sun. It is tilted maximum towards the sun. यहाँ पर ऐसे था. Okay, so with respect to you, if you can see, it's equal. है ना? ऐसे आके 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 it has tilted exactly towards you. So this is the maximum tilt. This is the maximum tilt. So with the maximum tilt, the sun's rays are reaching up to 23.5 degree north. So that means, so if you stand exactly on 23.5 degree north latitude on 21st of June, you will see 90 degrees of sunlight. So what about those regions beyond this? कहाँ पर दिखेगा? At 12 o'clock. They will not be able to see at 90 degrees. They will see somewhere over there. The sun will rise, it will come until set. The sun will never rise at exactly at east and come to 90 degree and set at exactly at west. For all the latitudes beyond this position, sun will always rise like this and it will come at an angle and it will set at an angle. है ना? I hope it is clear. The sun's rays always move from equator to 23.5 degree north, from 23.5 degree back to equator to 23.5 degree south. So you can see here, so this is equinox, 21st March. From here the sun's rays will start to move towards the northern hemisphere. It will reach to the maximum extent of 23.5 degree north. It will come back to, तो कब होगा यहाँ पर when it reaches, it is 21st of June. From 21st of June it will come back to the equator on 23rd of September. From 23rd of September it will come back to Tropic of Capricorn by 22nd December. From 22nd December it will come back to the equator by 21st of March. 90 degrees of sun rays will always between this equator, that is why we call it as between the tropics, the Tropic of Cancer and Tropic of Capricorn. That is why this region is called as the tropical region. They are always within the sun's 90 degrees of vertical sun rays, and beyond this none of the places will receive the 90 degrees of vertical sun rays. If the sun is here, this place will receive oblique sun rays. If the sun is here, this place will receive oblique sun rays. this will never receive 90 degrees of sunlight. So basically all the places between the Tropic of Cancer and Tropic of Capricorn receive the 90 degrees of sunrays at least 2 days in a year. One during the sun's movement from here to here, another during the sun's movement from here to here. So every place between the Tropic of Cancer and Tropic of Capricorn receives the sunlight, 90 degrees of sunlight, 2 days in a year. What about those places which are exactly located on Tropic of Cancer and Tropic of Capricorn? Only 1 day. Because sun will reach here on 21st of June and it will come back. On 21st of June all the places will receive 90 degrees of sunlight. On 22nd of December all the places across the Tropic of Capricorn will receive 90 degrees of sunlight. So here it's only 1 day, but here all the places would be receiving twice, 2 days in a year. One during the sun's motion from here to here, another from here to here. Here to here it will take 6 months, here to here it will take 6 months. Can you see December to June, June to December. So you can write the position of overhead sun, subheading, position of overhead sun. In that first point, on 21st of March, it is equator. (21st of June), Tropic of Cancer. 23rd of September, equator again. 22nd December, Tropic of Capricorn. Suppose if you are standing exactly in the north pole, 90 degrees north, you are standing exactly in north pole on 21st of March, ये तो 21st of March है. On 21st of March, sunlight is reaching up to north pole 90 degrees. है ना? So, but if you are standing exactly in the north pole, the point is stationary with one complete rotation, it is stationary. So, basically at this point, you will receive the sunlight for even after one complete rotation, but only across this. All the places below this will face the sunlight for 12 hours, will be away from the sun for 12 hours. When the earth comes from this position to this position, वो तो change हो गया. Can you see? It's not only across the north pole, even the sunlight is reaching beyond this point. Here the sunlight is reaching till north pole. Here the sunlight is reaching till 66.5 degree north. है ना? That means with one complete rotation, all the places beyond 66.5 degree north is completely receiving sunlight. So basically this portion which is receiving the sunlight for 24 hours of duration has increased from a single point to up to 66.5 degree. From 90 degree north mein tha, now it has come to 66.5 degree north. So why we have kept 66.5 degree north as Arctic Circle? This is the maximum position up to which the 24 hours of duration of sunlight will reach. Here it is only the north pole, exactly north pole, but here it is up to Arctic circle, up to 66.5 degree. That is why we have called 66.5 degree north as Arctic circle. That is the maximum position up to which we will have 24 hours of daytime. So that 24 hours of daytime would start to increase from 90 degrees to up to 66.5 degrees. Let's imagine a place here in between. At this position maybe it's 75 degrees तक आया है. Here it is maybe 85 degrees तक आया है. So here it is maybe 70 degrees तक है. Maximum it will come to 66.5 degree. I am telling the duration which is exposed to the sun all the time. Here you can see only the north pole is exposed, but as it is coming like this, more portion of this northern portion is getting exposed to the sun all the time. At its maximum position, the entire Arctic circle is exposed. So that is why we have kept Arctic circle at 66.5 degree. That is the maximum extent up to which the 24 hours of sunlight would reach. So that 24 hours of sunlight position, whichever the region is receiving 24 hours of sunlight, we call it as polar day. What is polar day? Polar day is when we receive the sunlight for 24 hours continuously. Even with one complete rotation, all the places are receiving 24 hours. वो कहाँ तक होगा? 66.5 degree तक होगा. I had shown you this, है ना? With one complete rotation, this entire Arctic circle is always towards the sun. तो यहाँ पर it's 24 hours of day. That is called as polar day or the midnight sun. Even at midnight you can see the sun. So you might ask, कैसे दिखता है? How it is visible? Midnight sun. Sun, how it would rise and set? Sun will never rise and set in the polar region. The sun will rise यहाँ पर. It will come all along the horizon. It will come by 12 hours. All along the horizon it will come back. It will never come to the overhead. Sun is always near to the ground. It takes a complete circle like this. That's why the sun rays are always slanting. So if this is polar day, the portion which is completely away from the sun is called as polar night. So I hope now you are clear why we have fixed the Arctic circle and Antarctic circle at 66.5 degree. That is the maximum position up to which the polar day and polar night would be experienced. From here the sunlight has started to reach till here, and now it will start to reduce. It will come back to 90 degree. From here, if you can see, this north pole will get away from the sun. यहाँ से तो north pole घूम जाएगा. Like if you stand exactly on the north pole, from here to here you are always exposed to the sun, and from once you start to move towards this position to this position, so you will always be away from the sun, even after 24 hours of rotation. So basically you stand exactly on the north pole, you will have 6 months of day, 6 months of night. I hope Durgesh doubt is clear. Durgesh Singh. So you have asked about 6 months of night and 6 months of day. Is it clear? 6 months of day would begin from here. So suppose you are standing here in the north pole. You are not receiving the sunlight. Is that right? From winter you have started to move towards here. So once your position has come to here, that is when the first light will reach the polar region, the spring. The first light will reach polar region at this position. यहाँ से यहाँ तक it's पूरा darkness. You will never see sunlight because you are always rotating away from the sun. Once you are positioned here, you will start to see sunlight, but you will see sunlight for the entire 6 months of duration. That is what is 6 months of day. And from here you are always away from the sun for 6 months. That is what is 6 months of night. Okay, you just write this, खत्म कर देंगे. The position of 24 hours of day and night. The position of 24 hours of day or 24 hours of night would be experienced from 90° north and 90° south. Okay, both 90° north and south up to 66.5 degree. 66.5 degree north and south respectively. And the polar regions exactly, and the polar regions that is exactly 90 degrees of north and south, the polar regions that is exactly 90 degrees of north and south would experience 6 months of day and 6 months of night. Harjot Singh is saying the length of the day should increase from Tropic of Cancer towards the North Pole, not from the equator. कैसे होगा? How is it possible? You can see equator always receive 12 hours of day, 12 hours of night, irrespective of its position in summer solstice or winter solstice, because the central part here is always along the circle of illumination. The central part here is always along the circle of illumination. From here, this portion, the difference would start to get widen. Here it is 12 hours, here it is 12 hours, here it is 13 hours, here it is 14 hours, here it is 15 hours, here it is 16 hours, maybe. It will widen from equator towards the pole. It will decrease from equator towards the pole. Okay, from equator, it's not from here. It would start from here, that divergence would start from here, not from equator. Okay, I hope that is clear. We have another query. Can you please specify which Orient Black Swan Atlas to buy? There is one named for competitive exam, another is 7th edition. Okay, let me just see which one I have. For competitive exam. Okay, you can buy for competitive exam. Orient Black Swan Atlas for competitive exam. So we have one query by Priyanka about the overhead sun. I think this would be more clear. Okay, before that I have another video. Let me just show you. I think that will make it more clear. Okay, it says the video is unavailable. Not sure. Okay, it says video is unavailable. Let me just see and share it in the next class. It's almost, it would have expressed in a better way. ठीक है. Position of overhead sun. This is equator. On March 21st, the sun's position is here. The sun rays are falling vertically 90 degree at equator Q. This is what is sun's position. The sun rays are falling because the earth is tilted either in this direction or in this direction. It's not towards it. The sun rays falls vertically along the equator. So that is what we call it as overhead sun. When I am saying overhead sun, exactly 90 degrees of sunlight. That is what is overhead sun. So from March, okay, this is March 21. This is June 21. From March 21 to June 21, the sun's position would change from here to here. है ना? Because at this it is tilted neither towards the sun nor away from the sun, and it is moving from here to here. And this position it is tilted to a maximum extent. And I'll show. So this is sun. March 21 it is neither towards the sun nor away from the sun, but here it is completely towards the sun. So basically at this position the sun rays are vertically falling at equator. At this position the sun rays are vertically falling at Tropic of Cancer. So sun's position, the 90 degrees of sunlight have shifted from here to here. That is, with every change in the day, the 90 degrees of sunlight is moving from equator towards the Tropic of Cancer. On 21st of June, it is falling exactly at Tropic of Cancer. Now from here, है ना, यहाँ से, it will come back to here again. At this September 23rd, again the earth is neither towards the sun nor away from the sun. That means the sun rays are falling vertically along the equator. So the 90 degrees of sunlight are moving from from Tropic of Cancer to the equator again. So we have one day, with every change in the day, I am telling, with every change in the day, one another place will start to receive. Maybe along the equator 1 degree, 2 degree, 3 degree, 4 degree, ऐसे change होते जाएगा 90 degrees of sunlight. Okay, so here it will fall on 1 degree or 2 degree, 3 degree, ऐसे change होते जाएगा. From 23.5 degree it will come back to here. So every place between these two regions would experience 90 degrees of sunlight twice. One between March 21st to June 21, another between June 21 to September 23rd. So after September 23rd till December 22nd, the position will come to here. From December 22nd, it will go back to here. So basically all the places will receive 2 days of 90-degree sunlight between these two. But what if it is exactly located on Tropic of Cancer and Tropic of Cancer? Only one day. That is on June 21st, on December 22nd. So I hope that is clear. So now I have a question. Let's see how many of you will answer this. So I told you three factors are important for the formation of seasons. One is rotation. Second one is tilt in the axis of rotation, and the third one is revolution. Suppose if I am saying there is no rotation, there is no tilt in the axis, there is just revolution. There is no rotation, there is no tilt in the axis, there is just revolution. What would be the result of this? What would be the result of this? Will there be seasons? Will there be day and night? For how long? What would be the result of this? Let's just see how many of you will be able to answer this. Please send your answers in the queries. If there is no rotation, there is no tilt in the axis, and there is only revolution. Okay, no seasons, ठीक है, no seasons तो मैं भी मानता हूँ. What would happen to day and night? So Sushant is saying day and night for 6 months. That means, what is the meaning of day and night for 6 months? 6 months of day, 6 months of night. Does that mean 6 months of day and 6 months of night? Aniket is also saying 6 months of day and 6 months of night. That is correct. 6 months of day and 6 months of night, Dhananjay, that is also correct. So basically there is no tilt, there is no rotation also. एक घूमेगा भी नहीं, ऐसे still. Let's assume you are the sun. Yashvardhan is saying half of Earth will have 365 day and 365 night. This is wrong. है ना, for half of Earth to continuously have day, continuously have night, वो तो नहीं होगा. For that at least one rotation should be there. तभी होगा. कैसे? I'll show. There is no rotation, there is no tilt. It's always towards you. है ना? It is moving, it is coming back like this. Okay, it is difficult to show to you. Let's assume that this is sun. This side is having day, this side is having night. This is sun. From here I have brought here and it is still here. So the same side which is exposed away from the sun, now it is exposed towards the sun. Can you see? So this is exposed away from the sun and I have brought, now it is towards the sun, now it is coming to away from the sun. So basically half the side will experience the day for 6 months, the same half the side, other half of the side will experience day for night for 6 months. That is correct. 6 months of day, 6 months of night. That is the answer. Okay, you can clear the rest of things. So now let me just show you some of the previous questions which was asked from this section. 2013 there was this prelims question. The variation in the length of day and night time from season to season are due to what? Now, variation in the length of day and night. Is it because of the earth's rotation on its axis? If the earth is just rotating on its axis, can we guarantee the variation in the length of day and night? No. The earth's revolution around the sun in an elliptical manner. Just because earth revolving around the sun in an elliptical manner, can we expect the length of day and night to change? Not necessarily. The latitudinal position of a place, is it because at equator it's always equal day and night? So it varies from one latitude to another? No, that is also not. It's the revolution of the earth on a tilted axis. Earth revolves around the earth with a tilted axis which is always fixed, है ना? Because of which the length of day and night would change. Answer is D. And we have this question which was asked in 2019. On 21st of June, what is the 21st of June? That is summer solstice. The sun does not set below the horizon at Arctic Circle. Is that right? Arctic Circle is completely tilted towards the sun. So that's why sun will never set below it. This is correct. What about this? It does not set below the horizon at Antarctic Circle. No. Antarctic Circle is away from the sun always. So it's always night. So this is wrong. Sun shines vertically overhead at noon on the equator. Is it so? Is it on 21st of June? No. It is on 21st of March or 23rd of September. Sun shines vertically overhead at Tropic of Capricorn. This is also wrong. ये कब होगा? Overhead at Tropic of Capricorn, 22nd of December. Answer is A. So we have a query. This is good. The polar day started shifting from North Pole to 66.5 degree. In the same time, polar night started to shift in which direction? From South Pole to 66.5 degrees south. That's correct. That's correct. So basically when we are at equinox position, both North Pole and South Pole are exposed to the sun. From equinox to summer solstice, North Pole starts to get more exposed. The region surrounding North Pole starts to get more exposed. So polar day ka region in the northern hemisphere starts to expand. At the same time, the polar night would start to expand in the South Pole. Polar night would start to expand from South Pole to 66.5 degrees south latitude. Good observation. I hope that is clear about the seasons. We have taken enough time. So we have one of the query by Devyansh talking about the point on great circle that shortest distance between two places on earth. कल तो मैंने दिखाया यार, इसके ऊपर भी दिखाया था. I had even drawn a map on this, how we can connect. Okay, let me just show you again. Suppose you want to connect two places. There can be multiple paths, but the shortest distance always lies on the great circle. You can draw circle like this, circle like this, circle like this, but it's only the great circle which connects in a shortest manner. And you take this example also. Suppose you are flying from, can you see here? You are flying from New York to Madrid. Madrid is in Spain. If you follow the equator, this is not lying on a great circle. I'll write it on, show you. If you follow if you follow the latitude from New York to Madrid. They are almost in the same latitude. Can you see? New York to Madrid, if you follow the latitude and if you follow the great circle, which one is shortest? The great circle is shortest because you connect these with the great circle, you will find them. है ना? Can always connect the shortest distance with the great circle. इसके बाद में भी if you are not able to understand, please don't worry much. इतना डिटेल में कोई पूछेगा नहीं. Nobody would ask about more mechanism. इतना तो याद रखो कि like if you connect two places on a great circle, that is always the shortest distance. है ना? So we don't have to do research here, right? So let's take a short break. After that, I'll continue. Fine. So I'll talk about the time zones and international date line. 5 minutes of break. So we have a query about this option A and B, the same question. On 21st of June, the sun does not set below the horizon at Arctic Circle. What does that mean? Can you see? On 21st of June, the entire regions beyond Arctic Circle is completely exposed to the sun. With one complete rotation, this region is always exposed to the sun. Even with one complete rotation, it is not coming under the darkness at all. Can you see all this region beyond the Arctic Circle? Arctic Circle to 90 degree, that is what is beyond the Arctic Circle. This position is always exposed to the sun. That means sun never goes down, sun never sets. That means it never goes down below the horizon. That is what is sunset. Only if it sets below the horizon, we can say sunset ho gaya. Sun does not set below the horizon at Arctic Circle. है ना? So option B कैसे होगा? इसमें क्या डाउट है? It does not set below the horizon at Antarctic Circle. ये कब होगा? When do we have this sun not setting below the horizon at Antarctic Circle? That is on 22nd of December. On 22nd of December, all the regions below this Antarctic Circle, so including Antarctic Circle, will not see night. The sun will never set below the horizon. Sunset ही नहीं होगा. Fine. So we have a doubt. During 21st March equinox, all the parts of the earth receive equal sunlight, whether north or south. Then why South Pole have polar night? No, South Pole will not have polar night. At this position, both the South Pole and North Pole will receive sunlight. But the North Pole will start to have 24 hours of sunlight from here to here. The entire region beyond North Pole up to this extent, it starts to expand from here to here. At the same time, after 21st of March, the South Pole will start to expand. The region around the South Pole will start to expand the darkness. The polar night will begin after 21st of March. On the day of 21st of March, both North Pole and South Pole will have sunlight. But the South Pole will start to have complete darkness beyond this point. From यहाँ से लेके यहाँ तक, it will never be seeing the sun. Can you see this is? And this is your, let me just show. This is your equinox. You can see both south pole and north pole. But from here, if I am bringing from here to here, at this position, can you see south pole? So in none of this position you can actually see south pole. Once at the equinox position you will see south pole, again you will see the south pole back at the next equinox. From spring equinox to autumn equinox, the entire south pole is completely invisible. That is what is polar night. And from spring equinox to autumnal equinox, the north pole is always visible to you. That is what is polar day. But how much of this region is visible? It will start from a single point and it will become complete 66.5 degree here, and from here it will start to reduce and it will become a single point over there. Same goes with the night. The polar night will start from a single point of south pole. It will become a maximum of 66.5 degree Antarctic circle here. The entire Antarctic circle is invisible and becomes lesser as it moves towards the autumnal. So now tell me, Mausam is asking, what happens to Arctic circle at equinox? The Arctic circle will have 24 hours of day. Kab? On only 21st of June, because that is the position which is more tilted. तब भी पूरा tilt होगा. Okay, how it would be visible? I have drawn the Arctic circle, you can see. At this, I would say this is equinox. Can you see 12 hours of day, 12 hours of night? है ना? It is exposed. But if it is somewhere like this, can you see? It is always towards you. So from here to here, कैसे change होगा? This region which is completely exposed to the sun starts to expand. It will start to expand until reach till the complete extent of Arctic circle. है ना? तो the regions which are located exactly on the Arctic circle will have 24 hours of day only for one day, that is on 21st of June, when it is completely tilted towards. यहाँ से फिर वो कम होते जाएगा, वो कम होते जाएगा to that extent that you can see only the north pole. Other than that, 12 hours of day, 12 hours of night. Meenakshi is asking how seasons will be affected from absence of rotation. So if there is no rotation, the day and night would not change at all. है ना? The day and night would not change at all. It's always constant. But if there is revolution, so that position of day and night would change once in 6 months. And it changes once in only 6 months. So Neha is asking, sir, how there will be 6 months of day and 6 months of night when only revolution will happen because the earth will be static, and why it will only revolve. I am not saying that it will revolve. I gave you a hypothetical condition, yeah. Okay, I gave you a hypothetical condition. 6 months of day and 6 months of night, the rotation would stop and only revolution. Revolution में क्या होगा? Earth is just going stationary along the sun. This would not happen. It is not possible. I just gave you a hypothetical situation, because here it is, this portion is exposed to you, okay, this is the sun, and here it is, this portion is away from the sun. So 6 months of day, 6 months of night, and from here to here, the entire this hemisphere is exposed. From here to here, the entire other hemisphere is exposed, and I am talking the other side of the earth. "24 hours of position." Okay, we have query again. Okay, listen to me carefully this time. I am explaining again about the 24 hours of day and 24 hours of night. Can you see this position? If you are standing anywhere in this, and the earth is rotating, what is the effect of this? All the places are always exposed to the sun. With one complete rotation, this is always exposed to the sun. When it is always exposed to the sun, sun is never setting. This is what is 24 hours of day. These positions with one complete rotation, that is with 24 hours of duration, this portion is never exposed to the sun. This is called as 24 hours of night. This is polar day, polar night. How the position would change? Here this entire region is experiencing polar day. This entire region is experiencing polar night. What about here? All of them are exposed. There is no region which is hidden. All of them are exposed. There is no region which is hidden. But here to here, the region which is completely exposed to the sun starts to increase. Here it is very single dot. Here it would be a small circle. Here it would be big circle. Here it will be much bigger circle, much bigger circle, much bigger circle, and the circle reaches 66.5 degree north. Kaise? Because the tilt starts to get aligned towards the sun. Here the tilt is parallel to the sun, but here the tilt is completely towards the sun. From here to here, how it would happen? Can you see? This is parallel, and as it is moving, the tilt is almost coming towards the sun. So that region exposed to the sun continuously has started to increase from only north pole up to 66.5 degree. From up to 66.5 degree to only north pole. The opposite would be in the southern hemisphere. From here, only the south pole, it is just a dot. The region starts to become bigger, 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 and it becomes completely, Antarctic circle. The region completely exposed to the sun is just a point here. From here, it will start to become bigger, bigger, bigger. From this, the entire Antarctic circle is completely exposed. So that is what is polar day in the southern hemisphere. I hope that is clear. We have taken more than enough time on the seasons. So next topic is time zones. So how do we calculate time? In the olden days, the time was calculated based on the position of sun. Watch वगैरह तब नहीं था, when we did not have the exact method to calculate time. How we used to say? It was approximate time. Morning, afternoon, evening, and then night. Morning when sun is near to the horizon, it is rising above the horizon. Sunrise हो रहा है. It's noon when the sun is its highest position. Sunset when the sun sets below the horizon. बाकी सारा it's night. Olden days. But the issue comes up when you have to think of what should be the time on other side of the sphere. You want to know the time because the time would be changing from one position to another because Earth is sphere. अभी यहाँ पर noon है तो in another place it would be sun rising, in another place it would be sun setting. है ना? The time across all the different places is not same. So we should have a synchronized time. There was a need to have synchronized time. मतलब we should be able to calculate the time of any particular place even though we are not in that place. Sitting here we should be able to tell what is the time in New York. है ना? तो हमारा, we Indians have this very peculiar habit. We call our relatives, friends who are there in the other countries, the first thing we ask them, what is the time over there? Did we call because of this? Is it the reason? No. We are curious to know क्या हो सकता है, इसलिए पूछते हैं. तो यहां से वहां ISD कॉल करके like we'll ask time. ठीक है, अभी तो WhatsApp कॉल है, फ्री है, it's fine. So how to find out? Suppose the other person is not telling. You should be able to find out all the time across all the different places of the globe by sitting in one particular location. That is the point here. It should make the communication easier, it should make the trade easier. Then only you can synchronize your activities. You get an order, you are an exporter, you get an order that you want on this day and this particular, before this it should reach. तो कैसे पता करना है? How will you find out? इतना time लगेगा वहां पर पहुंचने में, and वहां पर पहुंचने के बाद ये टाइम क्या होना चाहिए? This things is very 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 important for trade and communication. तो इसलिए we develop the concept of time zones. So how much time it would take for the entire globe to complete one rotation? With respect to sun, it is 24 hours. So we have divided the entire globe into 24 zones, 24 different time zones. And you can see, you can observe one thing, all across a particular latitude will have the same time. क्यों? Because this entire latitude is exposed to the sun at the same time. जो भी the place which is located on that particular latitude is always exposed to the sun at the same time. If it is here, if we are talking about India, okay, let's see, India के ऊपर कौन सा है? Central American countries, we have Russia here, we have Kazakhstan here, and Tajikistan, Kyrgyzstan, some part of China is also there. So can you see all the places would see sunrise at the same time, would see noon at the same time, sunset at the same time? All of them would have the same time. So basically one particular longitude, if you are able to catch one particular longitude, all of them would experience the same time at a given point. Either it should have morning, or it should have afternoon, or it should have evening. ये तो हमें confirmed है. So we divided the entire time of the earth into 24 zones. The entire earth into 24 time zones. And we can associate each time zone with a particular longitude. because it's the same all across that. So how many longitudes are there? We have 360 degrees of longitude. We have 24 time zones, each zone separated by the other by 1 hour of difference. Each zone would be separated by another one by 1 hour of difference. We have demarcated, हाँ ये वाला time है, ये this is this time zone, this is this time zone, with 1 hour of difference. So with 1 hour of difference, how much of longitude would be there? We have 360 degrees of longitude and 24 hours, that is 24 time zones. So each time zone should have how much of longitudes? 15 degrees of longitude. You divide 360 by 24, you will get it. Fine. Every 1 hour is separated by 15 degrees of longitude. This is 2 time zones, and if they are separated by 15 degrees of longitude, so that means if it is 5 o'clock here, it is 6 o'clock here. It would be 7 o'clock here. So that means with every 15 degrees of longitude increase or decrease, the time would change by 1 hour ahead or 1 hour behind. This is what is the concept of time zone. But some standard should be there. How to develop the standard? कहाँ से time शुरू होगा? कौन सा time zone we should keep it as a standard? So of course we have Greenwich meridian. The same Greenwich meridian has been kept as the standard for time zone also. The Greenwich meridian is taken as the standard time zone, and all the different time zones are measured either towards the east of Greenwich or towards the west of Greenwich. Towards the east of Greenwich we have 12 time zones, towards the west of Greenwich we have 12 time zones. That's why Greenwich is exactly at the half of this central time zone. So here we have 12 time zones, here we have 12 time zones. Each time zone differentiated with a gap of 1 hour each. So now we have given the choice to the countries. You choose whichever the time zone you want. But you have to choose and you have to declare to the world that I am choosing this time zone only, and our entire country will fix to this time zone. Suppose मान लो our India. So we have taken the time zone which is passing through Mirzapur. What is this longitude? We have 82.5 degree east longitude, which is considered to be passing at the center of India. 82.5 degree east longitude. So 82.5 degree east longitude है तो from Greenwich, how long it is? How much of difference is there from Greenwich? Divide 82.5 divided by 15 degrees. You will get 5.5 hours. You might know when you set the time zone, even in your watch, the olden days watch, or in your mobile, if you have to set, अभी तो automatic आ गया. If you have to set your time zone, it will show 5.5 plus Greenwich mean time. That means the Indian time is 5.5 hours ahead of Greenwich mean time, क्योंकि we are in the eastern part. Because sun rises first here, then only it goes here. Sun rises from here to, है ना? Sun rises in east and sets in the west. Is that right? So sun rises first here and then it is here. So that means we are 5.5 hours ahead of Greenwich mean time, because we are at the distance of 82.5 degree east from Greenwich meridian, the prime meridian. 82.5 degree का मतलब है 5.5. But there are many countries which will have multiple time zones. Take example of Russia. यहां से शुरू होके यहां तक है. So if you ask them to choose central time zone, it will be very difficult. क्योंकि here if it is the morning sunrise amounting to 6 a.m. and the entire country is following the 6 a.m. So basically यहाँ पर 6 a.m. हुआ है but sunrise has already happened. यहाँ पर 6 a.m. हो गया है, sun is yet to come, it is darkness. Sunrise would happen at 10 o'clock here. Sunrise will happen at night 2 o'clock here. For a country which has a very wider longitudinal extent, which has multiple longitudes passing through this, it will be difficult for them to follow a single time zone. That's why a country like Russia follows 11 time zones. It divides the country into multiple region and उसका boundary भी fix कर देते हैं, यहाँ से यहाँ तक you have to follow this, यहाँ से यहाँ तक you have to follow this, and they would synchronize accordingly. India में तो we have only single time zone. So what is time zone? Basically, in order to synchronize the time of every place, we have divided the earth into 24 time zones, and each time zone is in correspondence with a single longitude. And so each time zone would have a gap of 15 degrees of longitude. You can differentiate between two time zones with a difference of 15 degrees of longitude, and each country is free to choose whichever the longitude it is passing through. It is not necessary that they have to choose only the complete. The way we have taken 5.5 hours, many of the countries have taken 45 minutes, 15 minutes. It's not necessary that they have to take that particular. जो भी उसका central region में pass होता है longitude, they can choose that, but they have to declare they are in which position with respect to Greenwich. Maybe the Tokyo will say we are ahead of Greenwich by 10 hours. They have to stick to that. Everyone in the world will know that they are in the 10 hours ahead of Greenwich. New York will say we are at a distance of 5 hours from Greenwich, and once they announce that, everyone in the world will know they are at a distance of 5 hours. So from Greenwich Mean Time, GMT, the time will increase towards the east and decrease towards the west. Suppose if it is 12 p.m. here, it would be 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5.5 p.m. at India, 6 p.m., 7 p.m., 8 p.m. ऐसे it starts to increase, because at this particular time the sun, if it is 12 o'clock noon, sun has already passed from here to here, है ना? So maybe this is evening, but here the sun is yet to come. It is 11 a.m., 10 a.m., 8 a.m., 9 a.m., 8 a.m., 7 a.m., 6 a.m. The time would decrease. The time would increase towards the east and time would decrease towards the west. So we have a query that in the previous class I had told 1 degree has 16 minutes, that minute is different. So this minute is the time का unit है, and you divide the 1 degree. Each degree is divided into minute and each minute is divided into seconds. That is the division of degree. That is not the measurement of time. That is the measurement of latitude and longitude. उसको भी वहां पर हम डिग्री को भी डिवाइड करके मिनट बोलते, मिनट को डिवाइड करके सेकंड बोलते हैं, बट दैट इज नॉट द सेम मिनट एंड सेकंड ऑफ टाइम. दिस इज मिनट, दिस इज सेकंड, दिस इज डिग्री. सब डिविजन ऑफ ईच डिग्री. डोंट गेट कंफ्यूज दैट डिग्री इज डिवाइडेड इनटू टाइम, वो तो नहीं है. बट यू हैव राइटली सेड every 15 degree means 1 hour of difference. So 1 degree of longitude would have a difference of 4 minutes. That means with the shift of every 1 degree of longitude, the time will change by 4 minutes. You shift the longitude by 1 degree, the time will shift by 4 minutes. है ना, you move from Greenwich meridian by 1 degree towards the west, the time will reduce by 4 minutes. You move from Greenwich by 1 degree towards the east, time will increase by 4 minutes. If it is exactly 12 o'clock, it is 11:56 am, 12:04 pm. And India follows which one? We say Indian Standard Time, IST, that is 82.5 degree, which passes through Mirzapur of Uttar Pradesh. We have taken that as a time zone because that is at the center of India. So I'll give you a problem. Let's see. I hope you can solve this. So now it is clear. To calculate the time of any particular two longitudes, two particular places, if you know the longitude of these two places, you can actually easily understand the difference in time zone. So next time when you call your friends or relatives in USA or London, so rather than asking them the time, you can also ask them their longitudes, because we know our longitudes and you know the difference. You can calculate with every difference of 1 degree longitudes, there is 4 minutes. With every difference of 1 degree longitude, the time difference would be 4 minutes. I'll give you a time. I'll give you a problem now. Suppose you are in Mirzapur. Fine. You have gone on some work to Mirzapur. And who is the famous personality of Mirzapur? We have our Kalin Bhaiya. You know that? So Kalin Bhaiya is the famous personality of Mirzapur. So you go to meet him. And he gets a call from his son, Munna, who is there in Toronto. He has gone to Toronto to study. So Munna has got some good advice from some of the people. तो टोरंटो में अच्छा है, तो आप पढ़ सकते हो उधर. तो Munna is in Toronto. So Kalin Bhaiya calls his son Munna while talking. Kalin Bhaiya, as usual, like every other Indian, he asks what is the time over there. तो मुन्ना तो वहां पर जियोग्राफी पढ़ रहे हैं. He is studying geography over there. So rather than telling the time, he gives the longitude of Toronto, which is 77.5 degree west. Munna says it is 77.5 degree west, and he will tell आप calculate कर लो अपने आप. You calculate by yourself. Since you are there, तो Kalin Bhaiya says, please calculate करके बता दो मुझे. Please calculate the time for me. This is what Kalin Bhaiya has said, and he says that the Toronto का longitude है, it is 77.5 degree west, and the time in Mirzapur is 6 p.m. Let's see how many of you will be able to calculate. So Toronto's longitude is 77.5 degree west, and the time in Mirzapur is 6 p.m. So what is the time in Toronto? Let's see who will give the fastest answer. It is 6 p.m. It is 6 p.m. in Mirzapur. What is the time in Toronto? Whose longitude is 77.5 degree west? Okay, we have few answers. So let me just wait for some time and tell you guys what is the right answer. Okay, 1, 2, 3, 4, 5, 6. Till now I have got 6 answers and in that only 2 are right. I'll tell you who are right. You give me more answers, let's see. Let me see till top 10 and I'll give you the answer. 7 हो गया. Okay, we have got 3 right answers out of 8. Okay, 4 right answer. Let's see, one more. Okay, 10. So the person who has given the right answer and the first person to give the right answer is Ayush. Next person is Lalatendu, then Abhishek Pandey, then Harjot, and now Anmol. The answer is 7:20 a.m. It is 6 p.m. in Mirzapur. It is 7:20 a.m. in Toronto. I'll tell you how. What was the longitude of Toronto? 77.5 west. So Toronto is somewhere here. is 77 half west. What is the longitude of Mirzapur? 82 and half east. So what is the meaning of 82 and half east? 82 and half east means we are at a distance of 82 and half degrees from Greenwich meridian, which is considered to be 0. From 0 we are at the eastern part, 82 and half. Toronto is 77 and half west. That means from Greenwich meridian it is at a distance of 77 and half. So we are at 82 and half from Greenwich and Toronto is at 77 and half. To find the time between Toronto and Mirzapur, you should know the longitudinal difference between Toronto and Mirzapur. Not from Toronto to Greenwich and Greenwich to Mirzapur. You should calculate how much is the longitudinal distance between Mirzapur and Toronto. That one we'll find by adding these two. 77 and half plus 82 and half. कितना हुआ? 160. 160 degrees is the longitudinal distance between Mirzapur and Toronto. With every degree of longitude we will have 4 minutes. So 160 degrees of longitude will be at 640 minutes of difference. Convert this into hours. 640 minutes would be equivalent to 10 hours, 40 minutes. 10 hours is 600 minutes plus 40 minutes. है ना? I hope you can do this. 10 hours would be equal to 600 minutes plus 40 minutes. So the difference between Toronto and Mirzapur is 10 hours and 40 minutes. What is the time at Mirzapur? 6 p.m. So you have to go back from 6 p.m. by 10 hours and 40 minutes. You go back from 6 p.m. by 10 hours, you are at 8 a.m. on the same day. 10 hours पीछे गया तो you will be at 8 a.m. on the same day. और 40 minutes पीछे गया तो it is 7:20 a.m. From here it is 10 hours. From here 40 minutes. The right answer is 7:20 a.m. So Neha has sent at 7:22 a.m. That is not the right answer, right? 7:22 कैसे होगा? 7:20 is the right answer. Even though you had sent first, but the right answer is not that. $7:22 नहीं होगा यार. 7:20 is the right answer. UPSC के अंदर दोनों ऑप्शन होगा. 7:20 a.m., 7:20 p.m., 7:22 a.m., 7:22 p.m. दोनों होगा. ऐसे क्लोज ऑप्शन से रहेगा. It is not 7:22, it is 7:20 because exactly 40 minutes hai. From 8 o'clock you have to come back by 40 minutes, that is 7:20 a.m. I hope it is clear. ठीक है, many of the students are almost close, but I think they made a mistake in calculating. They are near to 7:20, 7:30, 8 o'clock, 8:30. थोड़ा सा, I think it's time for you to revise CSAT. So you can write briefly about this time zones. What are time zones? the regions of globe which observes uniform standard time. Uniform standard time. Entire globe is divided into 24 time zones. With Greenwich meridian as standard reference. With Greenwich meridian as standard reference. Full stop. From Greenwich meridian, the time increases towards the east. Time increases towards the east. And it decreases towards the west. Decreases towards the west. Next paragraph. A time difference of 1 hour, is equivalent to is equivalent to 15 degrees of longitude. Or 1 degree of longitude is equivalent to a time difference of 4 minutes. India uses, full stop, you can write in next paragraph, India uses 82.5 degree east meridian. India uses 82.5 degree east meridian as a standard reference for its time zone. Which is equivalent to 5.5 hours from Greenwich meridian or GMT, that is Greenwich mean time, 5.5 hours from GMT. So which country has the largest number of time zones? I told you the countries which have the longer extent with respect to longitude, that is, can say multiple longitudes are there. A country with multiple longitudes will have multiple time zones. A country with multiple latitudes For example, take Chile. Chile has multiple latitudes but very minimal number of longitudes. Which country is more having a chances of more time zones? A country with multiple longitudes. A country with fewer longitudes will have a single time zone. So which country has the highest number of time zones? It's not Russia, it's France. It has 12 time zones. Of course, the France located here is very small portion, but France has many international overseas territories located all across the different oceans, and all of them have their own time zones. So इसलिए France has nearly 12 time zones located, distributed all across different parts of the globe, and Russia has 11 time zones. USA also has 11 time zones. What about India? India, we have only one time zone. That is, India's time zone is set as per 82.5 degree east longitude. Whatever the time is here, we follow it all over India. Whatever the time is there along the Mirzapur longitude, we follow. मतलब सब लोग कालीन भैया को फॉलो करते हैं. Is that right? So this causes discrepancy, particularly in the northeast region, because India's longitudinal extent is not minimal. There is a difference of 29 degrees from easternmost to westernmost. The easternmost part of India is separated by westernmost part of India by a difference of nearly 29 degrees. 29 degrees matlab there is a nearly difference of 2 hours. From the central part, it's actually 1 hour of difference between the easternmost and westernmost extent. इसका issue क्या होगा? If the sun is rising at 6 a.m. in Mirzapur, here also it is 6 a.m. but sun has already risen here. Maybe the sunrise has happened at 5 a.m. itself. क्योंकि 5 am के बाद में once the sun has come to the easternmost part of Arunachal Pradesh, then only it has come to here. At 5 am there is no sunrise. Sunrise तो हुआ नहीं, but यहाँ पर तो 5 am पे sunrise हो गया. When 6 am sunrise is happening, it's already more brightness. What about here? In 6 am it is still dark. The sunrise will happen at 7 am here. Because India का longitudinal extent is also there to some extent. It is bit fine in this part, but northeastern they have some issues. They face the issues because of this. What would be the issue? Can you see, this is the actual picture. You can see Delhi sunrise would happen at 5:23 am and Arunachal Pradesh sunrise would happen at 4:20 am. I just gave an example over there. इसके वजह से क्या होगा? The people are not making use of the daylight to a great extent. Even though sun is rising at 4:30, they will get up at 6 o'clock only. They are not making use of the daylight in an efficient manner. That causes the mismatch in the sun's cycle and the activities. That causes the mismatch in the sun's cycle, the length of the duration and the activities. Normally activities should have started with the sunrise and it should have ended with the sunset. But यहाँ पर तो there is a complete mismatch. Even though there is sunrise, people are not getting up, they are still sleeping. Second one, this also causes more consumption of energy. They will get up late, they will go to sleep late. Rather than the sun setting at 6 o'clock, the sun is setting at 5 o'clock. But still people are awake till 11 o'clock. They have to use more electricity here. That is why the Northeast has been demanding a second time zone, especially for Northeast, for a long time. But we don't want to give this because of few reasons. What are the reasons? एक तो all the finance activities like banking, share market, everything is synchronized based on single time now. Now everything will be differentiated. Rest of the India, they would have their own time, Northeast will have their own time. Second, transportation mismatch, particularly railways. Railways, it is very, very important to have synchronous time zones, otherwise it will cause accidents. Every station should know कहाँ से कितने बजे निकला है, कहाँ से पहुंचेगा. Already railways run so much delayed. You introduce this, they would get much more reasons. And this will disrupt the transportation. Most importantly, the security reasons and communications. There would be mismatch, total mismatch between Northeast and the other parts. The communication delays or the security जो command होगा. So that would cause the disruption. Because of all these reasons, we are not accepting. ठीक है, थोड़ा सा if sun is rising early and setting early, थोड़ा सा adjust कर लेते हैं. That is the argument of government. So, but there is a local time called Chai Bagan. What is Chai Bagan? In some of the tea gardens of Assam, in that local areas only, they follow separate time locally. That they have been following since the time of British. So isliye they follow only in that tea gardens only. That is what is Chai Bagan time. Okay, they have some difference with the actual Indian standard time zone. Those people who are working over there, they just follow this and they come to the work and that particular time as per their time. Maybe they have kept bit early their time. That is what is time zone. Next, international date line. International date line. We have kept the time. Time तो हमने fix कर दिया using the different time zones. But we should have some point from where the date would begin. It is necessary that at some point some date should begin. From where there is a new beginning of the day. It is very much necessary for the calendar. कहाँ से day start होता है? So that line is called as international date line, and that line is coinciding with 180 degree east or west, which both are same. 180 degree east or west, and we agreed for this in 1884. In the year of 1884, all the people across the world, different leaders came together and they said, let's have a single particular longitude from where the date would begin, the date would change, so that all the countries towards this side will start to experience the new change in the date. Date begin would happen from here. That is what we call it as international date line. That is the line from where the date would begin. Of course, it's an imaginary line. But the issue is we have 180 degree east, but there are many islands in between who are lying exactly on this. So they would face the issue because some part of their island would be on this side of the international date line and some part would be on the other side of the date line. That means if it is 25 December here, it is 24 December here because यहाँ से date शुरू होता है. So some part of the island would be having 25 December, some part of the island would be having 24 December. Time would be same क्योंकि the same longitude. To avoid that, we have given crisscross. थोड़ा सा ऐसे adjust करके we have accommodated all the different islands. So that's why the international date line is not completely straight. And why did we not give Greenwich meridian as the time? Because Greenwich meridian, to as per our atlas, it is at the center of all the standard calculations. So new date should not begin from here. At the end, यहाँ से शुरू करते, the new date would start. That means the night 12 o'clock, 12 am जब यहाँ पर होता है, it is the new date, and the 12 am will start to shift like this. Whenever the 12 am is coming here, the date will begin. And यहाँ पर पूरा आके the 12 am comes back here, and the 12 am next when it comes, it has to change the date. We need one particular longitude where the date would change to the next day. Otherwise the 12 am 12 am 12 am 12 am आ गया, अब तो यहाँ पर भी आके 12 am 12 am 12 am वही डेट चलता रहेगा. We wanted one location कहाँ से डेट शुरू करना है, that is what is international date line. In the international date line, if you cross from east to west of international date line, the date changes but time remains the same. If you cross international date line, the date changes but time remains the same. कैसे? Suppose let's assume an island. Okay, there is an island. There are two islands, let's say. This is island A, this is island B. Both are separated by international date line. But they are located very close to each other. So here we have said the date would begin, so it is 25 December here. So here it is 24 December. Okay, अभी आया नहीं है. When the sun comes back here, the new day would start here. But since it is very close to each other, they are in the same longitude, the time would be almost same. Maybe there is 1 or 2 minutes of difference. So practically we will say there is no difference. If 25 December 2 p.m. it is here, so it would be 24 December 2 p.m. here. The time remains the same. दोनों बगल बगल में, टाइम का डिफरेंस नहीं रहेगा. It's like मिर्जापुर and बगल वाला village. Time is always same. But the date is different because they are separated by the international date line. So if we put this thing entirely across the globe, how it would happen? कैसे होगा? The international date line is at a distance of how many hours from the Greenwich meridian? 12 hours of difference है. And Greenwich meridian is from this part, okay, ये वाला part, that is 12 hours. Suppose it is 25 December 6 p.m. here. So let's say 6 a.m. It is 25 December, 6 a.m. along the Greenwich Meridian. What would be the date and time along the international date line? Like just on this side of the international date line. यहाँ पर अभी मॉर्निंग हुआ है, यहाँ पर ऑलरेडी मॉर्निंग खत्म हो गया. दैट इज टिल 25 December 6 p.m. There is a difference of 12 hours, but the date is same. बंद हो रहा है. The date is same. What about this side? This side मतलब ये वाला side. Can you see time should be same here? 6 p.m. ही होना चाहिए, बगल बगल में. But this is 24 December. Because from here to here time increases 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m. ऐसे होके 6 p.m. तक आया है. But time would decrease here. 6, 5, 4, 3, 2, 1 a.m. and it has come to 6 p.m. back. There is a difference between 0 degree and 180 degree west, 12 hours, and 0 degree and 180 degree east, 12 hours. Now I'll give you same thing. There is island A, island B. Both are located very near to the international date line, separated by international date line. Island B on this side of the international date line, island A is on this side of the international date line. This side is called as east of international date line and this side is called as west of international date line. You have to be very careful here. When I am saying east and west, you should not think ये सारा eastern countries है and ये सारा western countries है. If I am saying from east and west, it doesn't mean that you are crossing from here to here. If I am saying east and west of international date line, you are crossing from here to here. Don't get confused over there. If a person is crossing an international date line from east to west, if a person crosses international date line from east to west, would he gain a day or lose a day? Would he gain a day or lose a day? Let's see. Here it is 25 December, morning 6 a.m. Here it should be 26 December, morning 6 a.m. क्योंकि एक दिन आगे है. So if a person is crossing from east to west of international date line, he is actually losing a day. Losing a day कैसे? He gets up at 6 o'clock on the Christmas day, thinking he has the entire Christmas day, holiday है, पूरा festival है. But if he realizes that he is not on this side, but he is on this side, गलती से night ऐसे सोते सोते बोट में आ गया यहाँ से यहाँ तक. He was in the boat in this island. He had slept off. Boat had drifted off to this side of the island. So here he was thinking he has the entire full day, Christmas. He gets up at 6 o'clock. He sees here the Christmas is already over. 26 पे आ गया. So what has happened? He has lost a day. If a person crosses from east to west, loses a day. If a person crosses from west to east, he would gain a day. कैसे? He has spent his entire December 25th on this side. पूरा family के साथ, everything he has enjoyed, and he has slept off in his boat. The boat has drifted and it has come to this side by itself. He gets up at 6 o'clock and he sees again there is Christmas. ये तो धमाका हो गया, 2 Christmas. So he has basically gained a day. In his life, he has got one more extra Christmas, extra day. That is what we say, gain a day, lose a day. Remember, this is very confusing. If a person crosses international date line from east to west, he loses a day. If a person crosses international date line from west to east, he gains a day. It can also be asked in another way. What should he do in his calendar? If a person crosses international date line from east to west, he should add a date to his calendar. From 25 to 26, he should add a date to his calendar. If he crosses from west to east, he should subtract a date from his calendar. When you subtract a date from your calendar, you actually gaining a day. 25 से 24 आ गया, you have got another full 24th. 25 से 26 आ गया suddenly, you are adding a date to your calendar, you have lost the entire day of 24th. है ना? That is what is time zone. Sorry, international date line. So we have a very good question from one of the student. Areas closer towards the poles will have more longitude piling up closer to each other. Then what about the disorder in local time as they jump multiple time zones in relatively small area near the pole? Saurabh, very good. So that is why they don't follow multiple time zones as frequently as with respect to the longitude. And even though they have multiple longitudes over there, they would follow few time zones only. They would distance their time zones by larger longitudes. They would change the time zone after maybe 30 longitude or 40 longitude, क्योंकि area भी कम हो जाएगा ना. That is more practical. So Tushar is asking why not GMT for date line. So I told you GMT, it is said to be located at the center of the world map. So and usually we have the division of western hemisphere and eastern hemisphere. So to avoid all that, and moreover in here 180 degree there is lesser land. Can you see how much land is here? That would have caused more chaos. That was the safer option. Fine. So I hope it is clear. So let's stop here. And I will give you notes of this international date line in the next class. So please remind me that I am yet to give the notes for this topic. And yeah, I told you that I will take some map location, but इतना ज़्यादा explanation हो गया आज, particularly about the seasons. But still it is worth if it has clarified the doubts. Fine. So in the next class I am going to talk about the basics of cosmology. I am telling you again, only basics. I am not going to go in detail. Please don't ask doubts in specific. I am going to talk as much as it is required for geography only. In depth, the cosmology and the things related to space will be covered in your science and tech class, because few of the things are required in order to understand the evolution of Earth, solar system, all those things. So next class I will talk about that. Fine. If possible, please prepare a bit and come. So that will make the things faster. So that will help you understanding in faster. Fine. So you can refer to the space related things in GC Leong, the first chapter again. GC Leong first chapter. So that would be it. And some parts of your 11th standard NCRT. Okay, the second chapter where it talks about the evolution of solar system and Earth. So that I will talk about in the next class. Okay. So please revise and come. See you in the next class. Thank you.